Hello everyone, welcome to my YouTube channel. This is Enoch's tutorial. Don't forget to like and subscribe to my channel after watching this video so that you can receive every update from this channel. Thank you. In today's tutorial, we are going to look at the two ways of expressing concentrations. We have molarity and molality. We have other ways like the mass concentration and the rest. But in this video, I'm going to just focus on how to express concentration in terms of molarity and molality. Don't forget to like and subscribe as we said earlier so that you can receive every update from this channel. So let's begin. Molality of a concentration, or how concentration is expressed in terms of molarity, is defined as the number of moles per unit volume of a solution. That is the number of moles per 1 liter or 1 decimeter cube of a solution. So for every solution, we have the solvent in the solute in the solvent that make up the solution. So the number of moles expressed per 1 liter or 1 decimeter cube of a solvent to get the solution is what we define as the molarity. It is expressed here as the number of moles over the liters of the solution, or the decimeter cube of the solution. The number of moles here is expressed as the amount of substance in that object, and the amount of substance is defined as the mass of that solute over the molar mass of the solvent, or the molar mass of the solute. So the moles, or the amount of substance, is the mass of the solute expressed in the or over the molar mass of the same solute. Or moles of a substance is defined as the amount of that substance that contains the same number of elementary particles as there are in 12 grams of carbon-12. So by formula, we use the moles to be equal to mass over solute over molar mass of the solute. But by definition, we say the amount of that substance that contains so many elementary particles as there are in 12 grams of carbon-12. So let's see how we can express concentration in terms of molarity, that is the number of moles over the liters of the solution. Let's have some examples and see how best we can apply these formulas in calculating the various components of the solution. So this question says, what is the molarity of the solution if 3 moles of the solute is dissolved in 12 liters of solution? So you have a solution that contains, let's say, 3 moles of the solute dissolved in, let's say 12 liters of the solvent, or let's say 12 decimeter cube of the solvent. How do we express or find the molarity of the concentration of this solution in terms of molarity? So as we said earlier, the concentration of the solution is defined as the number of moles over the liters of the solution. So the moles we given here is 3 moles. We have 3 moles here dissolved in 12 liters of the solvent to give that solution. So we have the number of moles to be 3 and liters of the solution to be given 12. So the formula is just straightforward. It's just the number of moles, just 3 over 12, that gives you the 0.5. So this one means that the molarity of this solute is comprised of 3 moles of the solute dissolved in about 12 liters of the solvent to get 0.25 molar of solution. Let's take the next question. So you have here, so what is the molarity of a 400 milliliter solution containing 8 grams of sodium hydroxide? So here you have the solution given, or the solvent volume given in milliliters. So you have to first convert this one into liters or decimeters by straightforward dividing by 1000, and also the solution has been, or the solute has been given in grams. You have to convert it once into moles. So to convert a particular gram of a solute to moles, you just have to divide that mass over the molar mass of that solute. So let's start here. We have the mass of the solute here to be 8 grams. We have to change this one to moles. The liters of the solution is 400 liters. Milliliters, you have to change this one to liters by dividing by 1000. So for the formula, you have the moles of a solute because the liters of the solution as the formula to find the molarity of a solution. So the number of moles, as we found earlier, or as we saw earlier in the earlier formula, is equal to the mass of the solute over the molar mass of the solute. So we want to express this mass, this 8 grams of the sodium hydroxide, into moles of sodium hydroxide. So it's just the mass of the sodium hydroxide over the molar mass of the sodium hydroxide. So which is what 8 grams over the molar mass, and the molar mass is found just by summing up the atomic masses of the various atoms in the molecule. So the atoms in the molecule are sodium, oxygen, and hydrogen. So their atomic masses are respectively 23, 16, and 1. So summing them up gives you 40 grams per mole of the sodium hydroxide. And their mass given the question is 8 grams. So the resulting number of moles here is 0.2 moles of the sodium hydroxide. So it means that this solution, the resulting solution here has 0.2 moles of sodium hydroxide. Therefore, to express this one in molarity is just the mass or the moles of the sodium hydroxide here, which you find as 0.2 here over the liters of the solvent. Here we are given the liters in milliliters, so we have to convert this one into liters. So 400 divided by 1000 gives you the volume in liters. That is, this milli just means that 10 to power minus 3, and 10 to power minus 3 that is divided by 1000. So to convert this one to milliliters, just divide this value by 1000, and that gives 0.2 liters. So this liter is the volume or the resulting volume of the solution. Having got the number of moles to be 0.2 earlier, you have to just divide this one by the number of moles, or let's say the liters of the solution of the solvent to get the molarity of the solution. Let's see the next question. We have how many grams of calcium hydroxide are needed to prepare an 800 milliliter solution of 0.15 molar concentration. So here, this question, they have given you the molarity, they have given you the volume, and they have given you can get the molar mass from this compound, but you have to find the mass. So to find the mass is very simple. You just have to excuse me. So this question asks you to find how many says how many grams of calcium hydroxide are needed to prepare this volume of a solution of this molarity. So here you have to ask, or you have to find the grams, that is the mass of the calcium hydroxide in this 0.015 molar concentration solution. So first, just have to find the number of moles using the molarity and the volume. Then you use the resulting moles to find the grams using the molar mass and that moles. So here we have this one. The molarity to be equal to the moles of the solute over liters of the solvent. So the number of moles here is just enough subject. You have to just multiply this the liters by the molarity. So the moles is just molarity and liters. As we did earlier, first divide this one by 1000 to convert it to liters. So 0.15 times 0.8 liters gives the number of moles. So this concentration contains these moles of the calcium hydroxide. So how then do you find the mass? As we said earlier, the mass of a solution can be derived from the number of moles formula, which is equal to the mass of the solute over the molar mass of the solute. As we said earlier, the molar mass is just the sum of the atomic masses of the various components or the various atoms in the molecule. So the atomic mass of calcium is here is 40, that of oxygen is 16 times 2 as seen here, because we have 2 of this. Then oxygen or hydrogen is 1 times 2. So the molar mass of the resulting calcium hydroxide is 74 grams per mole. Therefore, having got the moles and the molar mass, you can find the grams or the mass of this calcium hydroxide by multiplying straightforward the moles which was found earlier and the molar mass which we just found. So this the product or this multiplication of this give us the grams of the resulting calcium hydroxide. It means that this concentration contains these moles of calcium hydroxide and these grams of calcium hydroxide. Now let's get to molality. We are done with molarity, which expressed the number of moles of the compound, or let's say the solute, in a liter of the solution, so of the solvent. Now with molarity here, molality, this one expressed as m, the small m. The molarity is capital M, whereas the molality is a small m. So this one, the definition is the number of moles per kilogram of the solution. Bear in mind the first one was the number of moles per liters of solution, but here it is number of moles per kilogram of the solution. So the small m is given by the moles of the solute over kilograms of the solvent. So the number of moles still remains, because the number of moles equals the mass of the solute over the molar mass of the solute. Let's see how we can apply these ones to in this calculation of the various entities in this formula. What is the molality of a solution containing 0.46 mole of solute in 2 kilograms? So this question is just a theoretical question that if you can think about it carefully, you can just even say it without calculating. If we are saying that the molality is just the number of moles in 1 kilogram, therefore if this is in 2 kilograms, then how many of this will be in 1 kilogram? It's just this one divided by 2. So this 1 over 2 gives you the molality of the solution. So let's see here, the number of moles or the moles of the solute is 0.46. The kilogram of the solvent is 2 kilogram. Therefore, the molality is just the number of moles or the moles of the solute over kilogram of the solvent. Therefore, it's 0.46 divided by 2, which gives 0.23 molarity. So this is the formula, or this is the unit of molality. Let's have this. What is the molality of a solution containing 75.5 grams of lead nitrate in 400 grams water? So here, first convert. This one is given in gram, therefore it must be converted to kilogram. Then this one is given in grams too. We have to convert this one also to moles. So to convert this one into moles, we have to find the molar mass of the lead nitrate by summing up the atomic masses of lead, nitrogen, oxygen in this compound to find it. So we have 207 for lead, we have 14 for nitrogen, and 16 for oxygen. So adding them up gives you 331 grams per mole. So this is the molar mass of the lead nitrate. That gives the molar mass. So the number of moles of the lead nitrate is just the mass of the lead nitrate over the molar mass of the solid. So we have 75.5, which is the grams of the lead nitrate, which is the solute in this case. Then 331, which is the grams or the molar mass of the lead nitrate. So it gives you 0.23 moles of the solute. So this one is the number of moles present in these grams of the solute. Then how do you convert this one to kilogram? It's very simple. We have molality is not known. We have moles of the solute we found to be 0.23 in the previous slide here. The kilogram of the solvent, which was at 400 grams, is just equal to 0.4 kilogram. That is divided this one by 1000. That gives you this one being converted to kilogram. Bear in mind, we said the molality is a kilogram of solvent, not grams of solvent. So if this one is in kilogram, you have to convert it to grams. If it's in grams, convert it to kilogram. Like the same way for the molarity, that if it's in milliliters, you have to convert to liters. So divide here by 1000 gives you 0.4 kilogram. Now we can just put the values in there to find the molality. That's 0.23 moles here over the kilogram of solvent, which is 0.4 kilogram. So this is the molality of a solution containing 75.5 grams of lead nitrate in 400 grams of water. Thanks for watching. This is Enoch's tutorial. Don't forget to like and subscribe to the channel so you can receive every update from this channel. Thank you.